greater than 2x minus 1, these kinds of problems.
Yeah. Oh.
So, it's kind of like y equals 2x minus 1. So how did we start that graph?
-1.
You go down 1, put a dot, then where do we go?
Then you go up 2.
Up 2, right 1, put a dot, put a dot. And then, you remember what we did after that? Is the line solid or dashed?
It's dashed.
Dashed because it's not equals to.
Yes.
And then did we shade above or below?
Below.
Yeah, this is read as y is greater than, so we need to go greater than line. So that would be all this stuff.
Good, and that's a good
Okay.
feeling.
That's kind of that's basically what we're doing today. Number 1 is actually kind of the trickiest, 1 through 4 is kind of the trickiest part. You guys ready? 1 through 4 is not graphing. Actually, the first graph is number 9.
Oh.
But it helps to look at a graph to figure it out. Do you guys remember what the quadrants were called?
1, 2, A, B, 3, 4. I don't know.
Because that's the way the C goes.
Yes.
A, B, C.
I don't understand it.
C, okay. So this part is probably confusing. You guys remember what the graph of x equals 1 looks like?
It's
Just
you
a
go
vertical line and
it's a line.
1.
Yes, you go to 1 on the x-axis and draw a vertical line. So what if they said x is greater than or equal to 1?
It's the
Right.
C to the right. Because
Anna, settle down. Girls, all the values greater than 1, all the x values greater than 1 are this way. So you would like shade all that. Now, here's the thing though. It actually says like x is greater than 0. Guys, girls, okay. What would x equals 0 look like?
go on the 0 and then you go.
So it's a vertical line. So remember x equals 1 was a vertical line through 1. So x equals 0 is a vertical line through x equals 0. Which is basically the y-axis. So what does x greater than 0 look like? All of this. Okay, why is all this x greater than 0? Because where are x values greater than 0? Where are x values positive at? Everything to the right. So this is x equals 1, x equals 2, x equals 3. Everything to the right would be x equals greater than 0. So if I said x is less than 0, that would be everything to the left. Like the second and third quadrant. Okay, what if I said y is greater than 0? Where are y values greater than y equals 0?
So it's up.
Is
It's 2
yes.
and 1.
Y values that are positive are up here, right?
Yeah.
Quadrants 1 and 2. Y values that are less than 0, that are negative, are down here. 3 and 4. Okay, number 1 says that. And the question is, what quadrant is that describing? So where are x values positive? 1 and 4. Where are y values positive though? 1 and 2. So where are both x and y positive? 1. So the answer to number 1 is?
Oh my gosh, that's such a coincidence.
Okay. Number 3 is x less than 0, y greater than 0.
Do we?
Okay. You don't. It's not a graphing problem.
Yeah.
This I'm just pointing at the graph to help us figure it out. Where is x less than 0 at? Yeah. All the x values are negative, less than 0, negative over here. Like this is -4, 2 or whatever, -5, -3. So all the x values are negative over here. So this is quadrant 2 or 3. Where is y greater than 0 at? We just did that one. 1 and 2. So x negative and y positive? 2. So the answer to number 3 is 2. You guys get it? Hopefully. It's kind of confusing. Number 5 says, for each system, now before today we've been solving systems of equations. Shh. Listen. It's just a screwdriver, it's not the end of the world here. We've been solving systems of equations. That's the sheet we just turned in. Listen, girls. By graphing, we used elimination, substitution, those things. Today is different because we're doing inequalities, not equations. So, on inequalities, the answers are not just like one answer. There's like all this shaded region represents an infinite number of answers. So if you say like negative 3, 2 right here, negative, guys, it's not funny. If you say like negative 3, 2, that's in the shaded region, that is one of the solutions. So you can't really say here's the answer because there's like an infinite number of answers. That's why we graph it. Anyways, number 5 says, for each system, determine whether the given ordered pair is a solution. So what do you guys think we should do at number 5? Put it in. If it works in both of them, we've done this a lot, right? If it works in both of them, yes, it is a solution. If it doesn't work in one of them, then no, it's not a solution. So on number 5 it says 2x. So 2 times 2 plus 3 times y, 3 times 3, is that greater than or equal to 5? Yes. 4 plus 9 is bigger than that. Yeah, so it works in the first one. And on the second line it says 2x plus y. So 2 plus 3, is that less than or equal to 7? Yes. So it works on both of them, so yes. Power drill. That's what it's called. Number 7. Same thing on 7. So I'm going to plug the 4. Where does the 4 go in on number 7 for the x? So it's actually 2 is less than or equal to negative 4 plus 6. What's negative 4 plus 6? 2. Is 2 less than or equal to 2?
Yep.
Okay, and then the second equation just says x is less than 4. So what do I do with that? Put the x in right there for 4. Is 4 less than 4? No. 4 is not less than 4. So the answer to number 7 is no.
How did you pull up? What is that again?
Those are,
Wait.
on number 7, I'm just plugging the numbers in to see if it works.
The X.
I just put the x value in for the x right there. Okay, number 9. Now we need a graph paper. This is very similar back when we did the graphing inequalities. There is a little bit of difference because we're graphing 2 inequalities. It's going to make a big difference. So number 9 says y is less than or equal to x minus 2. Where do I start the graph at? Down 2. Put a dot. Where do I go from there? Invisible 1. As a fraction, it's 1 over 1. So I'm going to rise 1 and run 1. So rise 1, run 1. Rise 1, run 1. Would this line be solid or dashed?
Solid.
Solid because it's less than or equal to the equal to part. So it looks kind of like that. Okay, but we're not going to shade yet because we still have to figure out the other graph. The other one says y is greater than or equal to 3x minus 5. I'm going to switch colors. You don't have to do this. If you want to borrow some pencils, I've got some. Does anybody want colored pencils? Okay. Where do I start this graph at? Down 5, so right there. And where am I going from here? Up 3, right 1. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Is this line solid or dashed? Solid. Okay, so what has happened when I drew these two intersecting lines is I created 4 regions between the lines. This is not part of the answer, by the way. I'm just kind of pointing this out. I'll say this is region 1, region 2 down here, region 3 down here, or region 4, all this stuff. One of these regions is going to be the answer. We're going to shade one of them in. You don't really need to write 1, 2, 3, 4. That's just to kind of point them out. So on my first line, which was my green line, it says y is less than. So that means it should be below the green line. So where is it below the green line at? Region 2 or 3, 2 and 3. But on my second line, my red line, it's y is greater than. So it needs to be above my red line. Where's 3 and 4? So what region did they have in common? 3. So I'm just going to shade in all this stuff. Okay. The directions also says list one point in your solution set. What do you guys think that means? It means find a point in your answer area, that's another way of saying it, and list it. So I just chose a random point here. This would be -1, -4. Okay, what does that point, -1, -4, have to do with anything?
Just to know that you got the right answer.
Okay, this is one of the infinite solutions that works. In other words, if we plug it in both of these inequalities like we did on number 5, it should work in both of them. All these points out here should not work, like 1, 2 or whatever. If I plugged in 1, 2, that's not going to work. Only the points in this region, like -1, -4, should work in both of those. You don't have to check it. You could, I guess, you want to make sure you did it right. But it asks for us to give them 1 point, so that's my 1 point. Mostly I'm just going to be looking at this graph, but we'll do that. Number 11. Y is greater than. Okay, where am I going to start that top one at? Up 6. I will make it blue. Where am I going to go from there? Down 2 and right 1. You can't go down 2 left 1 because that would be like both of these are negative, which would actually make it a positive. So I'm going to go down 2 right 1. Down 2 right 1. Is that line solid or dashed? Solid. All my straighter lines. Okay, then where am I gonna, I'll make this one red. Where am I gonna start that one at? Down 5. And where am I gonna go from there? Rise 1, run 3, up 1, right 3, up 1, right 3. Should that line be solid or dashed? Dashed. Okay, do you guys see the 4 regions? we should make this line longer. You see the four regions? Everything up here. Everything. It's a infinite region, but it just doesn't fit on my graph very well. Everything over here, everything over here. Now the regions, you don't really look at the x and y axis. That's not really part of it. It's just everything out here between lines. Okay, anyways, my first line, which was my blue line, it says y is greater than. So where would I shoot it? Like region 1 or 2, 1 and 2. In my second line, it says, my red line, it says y is less than. So where would I shade that? 2 and 3. So what region do they both have in common? 2. So I'm going to shade this stuff. And we're supposed to pick a point from the, what did they call it, the solution set. So what point would be in that region basically? 6, -4? Okay. There we go. Number 13. Says y is greater than 4 and y is less than or equal to -2 equals 3. Okay, y is greater than 4. What does y equals 4 look like? Good. So you go up to 4 on the y-axis and just draw a line through it, so it'll be a horizontal line. But if it's y is greater than 4, should the line be solid or dashed? So it's just that. Now, I'm not going to shade yet, but y is greater than 4. Which side of that line will we be shading? Above. But don't do it yet, because we got to do the other one first. Okay. On the other line, where am I going to start at? It's normal. So up 3. And then where am I going to go from there? Down to right 1. Or remember, you can also go backwards instead of down to right 1. You can also go up to left 1. Just make 3 dots there. Should that line be solid or dashed? Okay, on that second line that I just drew, the blue line, it says y is less than. So which side of that line should we be shading? Below. So below the blue line, but remember we said above the red line. So where would it be? Below the blue and above the red?
The upper, the 2.
The left.
Yeah,
Right there.
up left, right? Below the blue, but above the red. So that would be this area. Just marked over my work there. Actually, it's just the problem I copied down. Okay, 15, those are actually not graphs. They graphed it for us, but we're supposed to like say what the inequalities are. So it's kind of the opposite of what we just did. Let's start on 15. Let's start with the blue line because we just did something like that. What would that horizontal blue line be called? On 15. Huh?
Like we say the whole thing?
Just the blue line.
Y is less than or equal to 2.
Right. So yeah, it's now the blue line by itself would be called y equals 2. That horizontal blue line. But since we're shading below, it's y is less than, and because the line is solid, it's y is less than or equal to 2. So that's half the answer. And then the red line, so we're going to go back. So the red line has a slope and a y-intercept, so we're going to use slope-intercept form. But the red line is solid, and we're shading below it. So what inequality symbol should I use? Less than or equal to. And then next comes the slope, right? You guys remember y equals mx plus b. So I need the slope. I see that it crosses, the line hits at 0, 1 right there, and looks like it also hits at 3, 0 right there. So what's the rise and what's the run? Negative 1 is the rise, positive 3 is the run. So the slope is rise over run, negative 1/3. That goes in front of your x, and then what am I missing here? The y-intercept, the b. What's the y-intercept? 1. It crosses at 1 on the y-axis. And we put plus 1 right there. I think I forgot to put a point from the last problem, but that's okay. Skip that. Alright, anyway, that's it for 15. Alright, let's start with the blue line again, I guess. What is the slope of the blue line? Looks like it's crossing the y-axis at 4, and then it's also crossing at, or it hits a point at 3, 5. You guys see what I'm saying? Like, it's crossing at 4, and it's also hitting a point at 3, 5. So anyway, what's the rise and the run from? My graph making any sense? I'm drawing part of the graph from number 17. It's crossing at 4, and it's hitting at 3, 5 also. So what's the rise and the run? 1/3. So this time, it's kind of like the last one, but this time it's positive, right? Okay, I don't know why I did slope first next time. On 17, the blue line, it's shaded above, and the blue line is dashed. So what symbol should I use? Greater than, yes. Okay, the slope we already found was 1/3. So that goes in front of the x. And then what am I missing? Y-intercept, which is 4. It's a 4 on the y. Okay, that's the blue one. And then the red one, its red line is solid and it's shaded below. So what's my symbol? Less than or equal to. And my slope, it looks like it's hitting at 0, 2 on the y-axis. And where else is it hitting? 1, 4. Like right there. So what's the rise and what's the run? 2 over 1, which is just 2. Rise 2, run 1. So you don't have to write it as 2 over 1, you can just write it as 2x. And what's the y-intercept? Yeah, plus 2 right there. That would be it. Okay, last of the odds, number 19. What's different from how is 19 different from like number 9? Those problems.
Oh, it's in standard?
Standard form instead of slope-intercept form. So what do we need to do about that?
Get y by itself.
Yeah, get y by itself. So how do I get rid of the x? Minus the x. So remember, we didn't write 2 minus x. We actually wrote negative x plus 2. And same thing on the other one, x minus y. So we need to minus the x on this one. This one though is negative y is less than negative x plus 4. So what do I need to do about that?
Divide by -1.
Divide by -1. When you divide an inequality by negative, what happens? The inequality switches. Since we're dividing by -1, all the positive and negatives are going to switch also. So I got that one, I'll make that one a blue one, I got that one, be my red one. Okay, so where am I going to start out with this guy? Up to. Where am I going to go from there? Down one, right one. If you go left one, it will be wrong. So anyway, yeah, down one, right one, down one, right one. Is that line going to be solid or dashed? I think they're waiting to come in here. They're done with Mr. Adele's room. I might let you guys go a little early, but not like 2 minutes maybe. Oh. Okay, where am I going to start out with this other line? Down 4. And then where am I going to go from there? Up 1, right 1. Is that line going to be solid or dashed? Dashed. Okay, so I got the 4 regions. My first line, it says y is greater than, and my second line says y is greater than, after I solved it for y. So what does that mean if they're both greater than? Means you need to go above both of them. Where is it above both of them? Yeah, the regions don't actually have names, I was just making that stuff up. But yeah, the top middle, above both of them. I didn't lie, I just made some stuff up.
That's a lie. Oh, fake it to me.
Let's go shut up.
Okay, so just do the evens.